TIG. Ordinary liquid in thermometer. It consists of a glass stem with a capillary tube having a small bulb at one end. The bulb and part of the capillary tube are filled with a liquid, usually mercury or alcohol colored with dye to make it visible. The upper end of the capillary tube is sealed. Air is removed from it before sealing. A temperature scale is marked on the glass stem to indicate temperature corresponding to various levels of liquid in the tube. Working. On heating, the liquid expands and rises in tube. Use. The liquid in glass thermometer is commonly used in a laboratory. It has a temperature range 10 centigrade to 110 centigrade. Clinical thermometer. This thermometer is used to measure the temperature of human body, which remains in between 37 centigrade to 40 centigrade. So clinical thermometer has limited range from 35 centigrade to 43 centigrade. 95 Fahrenheit to 110 Fahrenheit. Construction. The glass stem of clinical thermometer has a narrow band in its capillary tube near the bulb. Working. This band helped to stop the mercury thread moving back toward the bulb after the thermometer is removed from the patient's mouth, and hence temperature can be read easily. Maximum and minimum thermometer. This apparatus is used to measure maximum and minimum temperature during a certain period. Construction. It consists of a fairly large bulb A which contains alcohol and connected through U-shaped tube filled with mercury from B to C. A second bulb of alcohol above O. Above O a space is present from which air has been removed. The left hand limb of the U-tube is graduated according to the expansion of the alcohol in AB. The right-hand limb is graduated so the expansion of alcohol in AB drives the mercury round towards D. Mercury surface will always point to the same number. Working. Expansion or contraction of alcohol in tube A due to variation in temperature causes a movement of mercury thread. In result of this, one or other index is pushed up or down by mercury and left in the extreme position reached over a particular period of time. This lower end of the index on the left indicates the minimum temperature and that of the right maximum temperature obtained. Thermos flask. It is an apparatus to keep the hot liquid hot and cold liquids cold for many hours due to conduction, convection, and radiation. Construction. It consists of a double-walled glass vessel. Outer surface of inner wall and inner surface of outer wall is polished. Surface in between the two wall is evacuated and then sealed. This bottle is placed inside a metallic case, resting in a cork at the bottom of the case, and is secured at the neck with a pad of felt or a ring of rubber. Working. Cork at the bottom, pad of felt and ring of rubber are bad conductor of heat, so heat cannot travel due to conduction. Vacuum in between the walls of bottle stop the convection, and bright surface of walls prevent radiation. In this way conduction, convection, and radiation are completely stopped, hence liquid inside the bottle neither will be able to lose heat, hence hot will remain hot and cold will remain cold. Thermal conductivity. Ability of a solid to conduct heat is called thermal conductivity, or it is the amount of heat in 1 second through a meter cube of a substance whose opposite faces are maintained at a temperature of 1 K. Mathematically expression. Consider a solid of thickness L and face area A. Two faces are maintained at same temperature T1. Heat Q is provided and due to this temperature reaches to T2 in time difference T. Then by combining all those factors here, A is the face area, L is the thickness, T is changed in time, and T is the change in temperature. K is the constant of proportionality which depends upon the nature of material and is measure of thermal conductivity. Unit. Thermal expansion. Increase in size, shape, or volume due to the increase in temperature is called thermal expansion. Explanation on the basis of molecular theory. As the temperature of solid is raised, the molecules vibrate through larger distance. The increases in amplitude of vibration of molecules causes an increase in average distance between them, thus solid expand on heating. Linear thermal expansion. Increase in length with the rise of temperature is called linear thermal expansion. Coefficient of linear expansion. Increase in length per unit original length per degree centigrade. Rise of temperature is called coefficient of linear expansion. It is denoted or it is fractional change in length per unit change in temperature. It depends on the nature of substance. Derivation for expression. If delta L represents the change in length of a rod whose initial length L when its temperature is changed by delta T, coefficient of linear expansion, unit of coefficient of linear expansion. Volumetric thermal expansion. Increase in volume with the rise of temperature is called volumetric thermal expansion. Coefficient of volume expansion. Increase in volume per unit original volume per degree rise in temperature is called coefficient of volume expansion. Mathematically representation. Experiment shows that is the constant n is known as coefficient of volume expansion. Unit of coefficient of volume expansion. From above equation, coefficient of volume expansion depends upon the nature of the substance.